Alright, so we're going to talk about the invertible matrix theorem and how like 5 of the theorems are basically equivalent. So we know that for according to the theorem for n times n squared matrix A is invertible if the following conditions are met. So we know that matrix A is row equivalent to the n times n identity matrix In, and to show this, if we set Ax equal to 0 and row reduce A will only have the trivial solution and be row equivalent to the identity matrix In. So we just have an example here where we let A equal to some 3 by 3 matrix, which would mean that n equals 3, so we have the identity matrix I3, and we set Ax equal to 0, and if we row reduce, we get this form, which is row equivalent to what we have here. So A is row equivalent to the n times n identity matrix I3 in this case. For number 4, it says that columns of A form a linearly independent set. From above, we know that A is row equivalent to the n times n identity matrix In. So this means that Ax equal to 0 has only the trivial solution, and we can see that here. So we know that the columns of A form a linearly independent set, and this connects to number 13, where it says that the column space of A is equal to R to the n. From above, we know that columns of A form a linearly independent set because there's a pivot position in every column. This means that there's so the column space of a matrix is the span of its column vectors. So therefore, we know that like the column space of A is equal to R to the n because there's a pivot in every column. And this connects to number 16, where it's the null space of A is equal to 0. The null space of a matrix is equal to the columns in the reduced row echelon form that do not have pivots. But this basically shows that this is independent, so there's pivot in every column. So we know that null space of A is equal to 0. And lastly, number 15, the rank of A is n. We know from the formula that call space is equal to rank plus null space, and we can isolate to solve rank here. And from above, we know that call space is equal to R to the n and null space is equal to 0, so we know rank is equal to n.